In Lesson 2.2, we're just going to be continuing on with what we talked about in Lesson 2.1, which is solving equations. Now we're just going to be introducing multi-step equations, so more than two. And I'm going to go ahead and list the order of the steps you should follow when you're solving these, but for today's lesson and tomorrow's assignment, we're only going to be going through the first half of Lesson 2.2. And we are not going to be dealing with any fractions or decimals. In tomorrow's lesson, we'll talk about fractions and decimals. So these are the steps that you're going to follow in the order as you solve these equations. First thing you always want to do is you want to clear any fractions or decimals. So this is the part we'll kind of skip for tomorrow's assignment, since we won't have any in there. Second, you always want to look to see if there's anything that you need to distribute. And there's a couple ways that you can deal with distributing, so I will show you both as we go through. And I can also show you more and help you practice it in class if you need help. Third thing you're going to look for is collecting like terms when they're on the same side of the equation. So we're not talking about moving things across that line that I've been drawing. We're talking about on the same side. That's part of the reason I have you drawing that line. So just put not across the equal sign. Then you're going to start to work on isolating the variable using everything that we've already been doing. So isolate the variable using inverse operations. And you always want to add or subtract. Then multiply or divide. Oops. Sorry. There you go. So you're going to isolate the variable using the inverse operations, and then you're going to add or subtract things to isolate it, or then multiply or divide. Only time that this wouldn't be true is like the example in Lesson 2.1 where you had more than one thing in the numerator and you had something in the denominator that you needed to get rid of. Then you would multiply first. That's the only time. Alright, so let's go through a couple examples. Hit pause if you're still writing. Otherwise, go ahead and move on to the examples. Example 1. Solve 2c plus c plus 12 equals 78. Okay, so always look for your variable first. Also think about drawing that line out of the equal sign. So you're only doing inverse operations if you're trying to move across that line. Otherwise, you're just combining things and doing what you would normally do with simplifying. So when I look on this side, I have no fractions or decimals to clear. I have nothing to distribute, but I do have like terms that I need to collect. So I'm going to start there. They're on the same side of the equation. 2c plus 1c is 3c. Remember, that's a 1 there, and you add your coefficient, so 2 plus 1 is 3. 3c plus 12 equals 78. So I'm not using the inverse operation because I'm not moving it across that equal sign. Now I have just one variable, which was my goal. Now I'm going to start to isolate the variable. And I'm going to always add or subtract before I multiply or divide. So inverse operation would be to add a negative 12 or to subtract 12, whichever way you want to write it. As long as you're getting your signs correct, I don't mind. So now I have a 3c equals, these became 0, 78 subtracting 12 is 66. Now I need to use inverse operation again. 3 is multiplying to c, so the inverse operation would be to divide. So I'm going to divide both sides by 3. Remember, this becomes a 1. So I have 1c, which is just c. c equals 22. And then in order to check that, now I'm going to plug 22 in every time I see a c and evaluate the original equation. So when I go to check, 2 times 22 plus 22 plus 12 equals 78. 2 times 22 is 44, plus 22 plus 12. 44 plus 22 is 66. 66 plus 12 is 78. So I did that correctly. Alright, let's try another one. Example 2. Solve 8x plus 16 subtracting 2x equals 46. So same thing. You don't always have to highlight the variables. I'm just trying to help those of you who might be having a little trouble remembering kind of a starting place. Highlighting those variables sometimes helps. And then everyone should be drawing their line at this point just to make sure you're doing that correctly. So I noticed that I have the variable twice on the left. So I have like terms. I didn't have fractions, I didn't have decimals, and I didn't need to distribute. So I'm down to collecting like terms. They're on the same side, so I just combine them the way they are. It's 8x minus 2x. So you should have 6x plus 16 equals 46. Now you have an equation that looks like what we've been doing. Now you're going to go ahead and add or subtract first. In this case we're subtracting or adding a negative. 16's become a 0. 6x equals 30. And now multiplying, so we're going to divide. And x equals 5. Now, just to speed up the notes, I'm not going to check every one of these, but when you're doing these, you do need to check them. So 8 times 5 is 40. 40 plus 16 is 56. And then if I was to evaluate with a 5 here, a negative 2 times 5 would be a negative 10. So 56 subtracting 10 is 46. Example 3, we're still solving. Negative 2 times the quantity, which means parentheses, x subtracting 4 equals 12. So there are actually two ways to solve this. I'm going to show you both ways because some of you might understand why the first way works or the second way works. And you might like using that, but it can get confusing, so you just have to make sure you're only using it when you really should be. So first way, I'm just going to rewrite the problem. We don't have fractions or decimals to deal with, but if we look at our second thing we're always going to look for, that's distributing. So you would go ahead and distribute. negative 2. So you have a negative 2 times x, which is a negative 2x. And you have a negative 2 times a negative 14. Don't lose that. So a negative times a negative is a positive 28 equals 12. And now everyone should see how to solve that from there. Here's your variable. You have no like terms to collect. So now you're just going to start moving things away. Inverse operation would be to subtract 28. You have to be careful here because you have a negative 2x left over and you have a negative and a positive. So you need to find the difference and then the sign from the larger absolute value number. So the difference between 28 and 12 is what you're looking for first. And everyone should have a negative 16. Now you're going to go ahead and move the negative 2. It's multiplying, so opposite would be dividing. So you divide both sides by negative 2. You want the negative to go over with it because you want x fully isolated. And now you have x equals a negative divided by a negative is a positive. 16 divided by 2 is 8, so a positive 8. And if you were to check that, 8 subtracting 14 is a negative 6, and negative 6 times a negative 2 is a positive 12. So for this one, you're going to distribute, then solve. The second way you're going to divide both sides by the number outside the parentheses. And the reason that this works is because if you think about it, you multiplied to each of these terms. And so if you go ahead and divide before you do that, you haven't really changed anything. It's different than once we were here if we were to divide just this side and this side by 2. You're actually dividing because of that 14 being multiplied by it also. You're actually just dividing it and getting rid of it first. So if you have more questions about that tomorrow and you want to try it this way, ask me. Otherwise, I recommend you just use the first way. So we'll start with the same problem again. We had negative 2 times x subtracting 14 equals 12. So now I'm kind of going against what I've been told, which is usually I add or subtract first, but because I've got this set of parentheses there, I want to get rid of that negative 2. Instead of distributing, it's multiplying, so I'm going to divide. Now I have x subtracting 14 left here equals negative 6 here. Then I'm going to isolate my x. I'm going to isolate it by adding 14 to both sides. Notice I'm using signs. Always use signs. X equals positive 8. So same answer. Doesn't matter which way I do it. Alright, last example. Over there. 15 equals negative 3 times x subtracting 1 plus 9. Okay, so I just talked to you about the fact that you could divide right here. The problem is you can only do that when this is all you have on one side. So if you're going to do this the second way, you would need to subtract 9 first. Now you have this multiplying to each thing. That's when you can go ahead and divide. I'm not going to show it to you that way. If you want to try that way tomorrow, just ask me for help if you run into any problems with it. But just remember, this needs to be multiplying to everything over there before you can use that trick that I showed you as the second way. So you would subtract the 9, then you could divide both sides by negative 3. I'm going to go ahead and show you just the distributing way. So we'll go ahead and distribute. So 15 comes down. I distribute negative 3, and negative 3 times x is a negative 3x. A negative 3 times a negative 1, positive 3. You need to remember negative times negative is positive. You don't just use one of the signs. And then I'm just adding 9. I'm not multiplying negative 3 to that. Okay, now I look for my variable. My variable happens to be on the right, which is fine. And I look for like terms that I can collect. Here are two like terms. They have no variable at all, and they're on the same side of the equation. So I'm going to go ahead and do that, and I have 15 equals a negative 3x plus 12. Now I'm just continuing to work on isolating my variable. So I'm going to go ahead and subtract 12, inverse operation. I have 3 equals negative 3x. Now I'm multiplying here, so I need to do the opposite inverse operation, which is divide both sides by negative 3, and I have negative 1 equals x. That's today's lesson.